Okay, our next one. Next problem, number 10. So, what do you know? Straight away, you notice that there's 1, 2, 3 different functions of x there, involving multiplication and division. If there's more than 2, we're not interested in the product and the quotient rule. Okay, it can be done, but we are not interested if there's more than 2 factors involved. Right, so why do we learn log differentiation? Is for problems like this here. So what we're going to do is introduce, learn on both sides. So I'm going to go learn absolute value of both sides there. That's going to be x cubed times inverse cos, all divided by an x. So you introduce learn on both sides. Why do you do that? So we can separate this into 3 different terms. At the moment, it's just one term with 3 factors here. We want to separate it into 3 different terms. So it's going to be ln of the first one, which is x to the power 3 there, plus ln of inverse cos 2x. And whatever's below the division sign, we put a minus, and it's minus ln of the next. Let me take out this. So minus ln of ln. So that is my ln of y. Okay, now let me differentiate it as it is. I can simplify it. I'm not interested in that. Not much to do here. I can bring down this 3 here. Okay, if I want to. But if I don't want to, I don't have to, because you can differentiate it as it is. So now what am I going to do? I'm going to differentiate both sides. So I'm going to go d over dx on the left and d over dx on the right. So when you write down d over dx, what does that mean now? When I write down d over dx, it means the next thing that I'm going to see here, the next step is going to be the derivative of ln y. If I write down d over dx here, that means in the next step I will see the derivative of ln of x cubed of everything. Right, so that's why you write down d over dx to indicate that you are differentiating. Okay, so now to indicate that you are now differentiating on the left-hand side, this is implicit differentiation, because the derivative of ln y, you're dealing with the variable y. With respect to x, you differentiate, that is 1 over y, and you multiply by dy over dx. Implicit, that's a shortcut, implicit differentiation. You just remember multiply by dy over dx. Let's deal with the right-hand side. Ln of x cubed. So what are we dealing with here? We are dealing with the ln of f of x. So the formula to differentiate ln f of x is going to be f prime x, all divided by f of x. So we're dealing with that. So here, the derivative of x cubed is going to be 3x squared, all divided by x cubed. Term 2, you're dealing with y is equal to inverse cos. Let me call this p of x. Right. So then dy over dx, the derivative of inverse cos. I'm forgetting about ln now. Right, I'm just talking about inverse cos. We already know what's the formula for ln there. So inverse cos will be minus p prime. Okay, I'm using p, so I'm calling it p prime. If it's f prime. Doesn't matter. All divided by the square root of 1 minus p of x all squared. So now let's go back to this. So we got ln f of x. The formula is f prime x over f of x. Okay, so this whole thing here is my f of x. Take f of x, copy it in the denominator. There's it here. Now differentiate it and write it down on the top. F prime x means differentiate this. How do you differentiate this? You go to your inverse trig table. It's either in your head or you copying it down from somewhere. Right, so the derivative is going to be minus f prime or minus p prime x, which is minus 2, all divided by the square root of 1 minus, so that's going to be 1 minus. This is your p of x, which is 2x. And it's all squared. So that sorts out term number 2. Term number 3. Same story here, you can see ln of f of x, take f of x, copy it in the denominator, differentiate f of x, write down the result in the numerator. The derivative of ln x is 1 over x. The numerator is a derivative of the denominator. Very important words which you will see when we deal with integration. It's the same thing, the numerator is a derivative of the denominator. Okay, so what must we do now? Multiply by y on both sides. Make dy over dx the subject of the formula. So dy over dx is equal to, I multiplied by y and y, sorry, by y over 1, by y on the left, y on the right. So that's y there. Simplifying, how I'm going to simplify here, it's a fraction divided by a fraction. I'm going to simplify that here, x squared over x cubed. I'm going to simplify here, fraction divided by fraction. I'm going to simplify everything. Okay, so now we got 3 all over x squared will cancel with x squared, so you end up with 3 over x. Here, a positive times a negative is a negative 2. This is inverse cos 2x times the square root of 1 minus 4x squared. I'm simplifying my fractions. Here 1 over x divided by ln x is going to be 1 over x ln x. Close bracket, there's nothing more to simplify here. So let's just leave it as it is. And that was the second example. Right, so the next example here. Well, there's no multiplication and division of 3 factors, just 2. Like here, this is multiplication. Here, this is multiplication. So, you know how do you know that this is multiplication? There's no sign in between negative x and ln y. There's no sign that you can see. That means automatically it's multiplication. Okay. So now, what do? You know what to do. You're going to go d over dx on the left-hand side, d over dx on the right-hand side. Right, so now, on the left-hand side, you differentiate 2y squared. The derivative of 2y squared will be 4y multiplied by dy over dx, implicit differentiation. Now here, the product rule. So I'm going to take minus x as my first factor and ln y as the second one. Okay, so product rule, yeah. So let's say if I got minus x times ln y. So I'm going minus x as u and v as ln y. So those are my two functions. Right. So the product rule, you know, is u v prime plus v u prime. That's a product rule. So let me re-explain here the product rule. I'm going to copy down the first times differentiate the second. The derivative of ln y is 1 over y multiplied by dy over dx. Every time you differentiate the variable y, multiply by dy over dx. So you write down the first, there's the chair, differentiate the second, plus write down the second, which is ln y, and differentiate the first, which is going to be minus 1. The derivative of minus x is minus 1. So that is the left-hand side sorted. Now the right-hand side. The right-hand side here, the derivative of inverse sine of x, which I just wrote down the formula for number 8. So that's going to be 1 f prime x all over the square root of 1 minus f of x all squared. So that's going to be 1 minus x squared. Plus, now read this, y, there's no sign, that means y multiplied by cos x all raised to the power 3. So therefore this is the product rule again. See that? So the product rule is write down the first, which is y, differentiate the second. Be careful, cos to the power 3. You have a power which is a number, so therefore you are using the chain rule. So that's going to be 3 cos. 3 minus 1 is 2. So you deal with the power first, times. Now you're going to differentiate cos. The derivative of cos is minus sine. Times the derivative of x, which is 1. I don't have to write that down. So copy the first, differentiate the second, plus copy the second, which is cos cubed. And now differentiate the first. The derivative of y is 1 multiplied by dy over dx. So the main job is done. Now we need to make dy over dx the subject of the formula. That means take all the dy over dx's on one side. Okay. So I've got this term, that term, and that one there. Let me take all to one side. So I've got my 4y times dy over dx minus x over y times dy over dx. There's one more here. So this is going to be minus cos to the power 3 times dy over dx. And those are the only terms that have dy over dx. Take them to one side. Anything else to the other side. So what do I have here? 1 over the square root of 1 minus x squared. Positive times negative, that's a negative 3y cos squared x times sine x. Is there anything else that needs to be on this side? Yes. You have minus ln y on the left. When you take it to the right, it becomes a positive ln y. Okay, this is a minus ln y. So when you take it to the right, it becomes positive. Okay. Now, basically I'm just manipulating the formula. The main job is done now. So take out dy over dx as a common factor. So now I'm left with 4y minus x over y minus cos to the power 3. And on this side, I'm left with just 1 over the square root of 1 minus x squared minus 3y cos squared times sine x plus ln y. Divide, and then I'm done. Problem solved. So now dy over dx is equal to, on the right, you've got 1 over the square root of 1 minus x squared minus 3y cos squared times sine x plus ln y, all divided by 4y minus x over y minus cos to the power 3. Do we need to simplify any further, or is this the textbook final answer? It says number 14. Let's check. No, the textbook final answer is the same as mine, so they did not go and simplify, but it can be. This can be simplified further. I can find LCD here, I can find LCD there, but I'm not going to get into that. I'm just going with the textbook final answer. But the fact is, this can be simplified further, but this is the correct solution. So when you are reading the problem, if you're reading wrong, you're going to write wrong. Remember that. If you don't read this as x ln y, read it as x multiplied by ln y. Every time you see us, no sign there, you say multiplication, okay, or times, whatever you used to. Let's move on to the next one. All right, so here's the next one. Now, be careful. You see E there, and there's two terms on the right-hand side. So if I give you ln of 2 times 3, okay, ln of 2 times 3, this is equal to ln 2 plus ln 3. Alright, you can verify this on a calculator. If I give you ln of 2 plus 3, this is not equal to ln 2 plus ln 3. Be careful. If there's a plus sign, you cannot remove brackets with log logs. Okay? So do not go and introduce linear because there's a plus sign. This is not a multiplication sign. Okay, only when it's multiplication and division, then you introduce len. You're going to take a problem and make it even more complicated. Okay, if you introduce len. So this is the problem that can be worked out as it is. There's no need to introduce len on both sides. So what we're going to do is d over dx on the left, d over dx on the right hand side. So what are we differentiating? E. So now let's go back to our table of derivatives. If y is equal to k times e to the power, let me just leave out k here. Just e to the power f of x. If you have e to the power f of x, then the derivative will be e to the power f of x multiplied by the derivative of f of x, which is f prime x. You're clear with that? So now, the derivative of e to the power xy will be e to the power xy times the derivative of xy. Now I'm saying xy. There's no sign in between x and y. That means it's x multiplied by y. So if it's multiplication, we use the product rule. Open up a bracket. If there's no brackets, this whole thing is wrong. You must open up a bracket here. Now, product rule, write down the first, which is x, differentiate the second, which is y. Differentiate y, you get 1 multiplied by dy over dx. So that's write down the first, differentiate the second, plus write down the second, which is y, plus write down the second, which is y, and then differentiate the first. The derivative of x is just 1. Left hand side, sorted. Now, right hand side. So, the derivative of x squared is 2x plus, we're dealing with e to the power something. There's a chair. Same story here. You can see that. E to the power f of x, or e to the power inverse tan is e to the power inverse tan times. Now we need to differentiate inverse tan. Let's write down the formula here. If y is equal to inverse tan f of x, y prime, the derivative of inverse tan of f of x is f prime x all divided by 1 plus f of x all squared. So the derivative here is going to be 1 all over 1 plus y squared. But remember that this is the variable y, and when you differentiate y, you've got 1, you need to multiply by dy over dx. Okay, multiply by dy over dx. Now, the main job is done. Now we need to make dy over dx the subject of the formula. I have to remove these brackets here first. So let me remove the brackets. So now that's going to be x times e to the power xy times dy over dx. E to the power xy times y is y e to the power xy. Here, nothing for me to do on the right hand side, so that's just 2x plus e to the power inverse tan y over 1 plus y squared times dy over dx. Take all your like terms, all your dy over dx's to one side. I always take it to the left. You don't have to take it to the left. You can take it to the right if you want to. There's two sides. Okay, so now I got my x e to the power xy dy over dx. Take this to the left, minus e to the power inverse tan y all over 1 plus y squared times dy over dx. So I've got all my dy over dx's on one side. Whatever does not have, keep it on the right. So that's 2x minus y e to the power xy. Take out a common factor and divide. This is all simple things to do here. You can see that dy dy over dx. There's a common factor, so that's x e to the power xy minus e to the power inverse tan y all over 1 plus y squared is equal to what you have here, 2x minus y e to the power xy. So make dy over dx the subject, and then you're done. So that's going to be 2x minus y e to the power xy all divided by x e to the power xy minus e to the power inverse tan all over. Is that the correct solution? You got the same thing. So I just chose a few examples. You can see it involves a bit of everything here. Continue next time.